Alright, welcome back to Meteorology 101. Just want to do a quick video, look at a couple systems going on out throughout the United States. Got a little bit of convection through Minnesota, stretching down into South Dakota and Nebraska. So pretty intense low pressure system off the New England coast. Get some wraparound moisture right over there into Maine, causing some rain showers. And then high pressure to the southeast, and you can see the uh, looks like a lot of cirrus spilling over that ridge, over that high pressure system over the south, and then maybe a frontal boundary extending down through the central U.S., and then maybe a little bit more ridging going on over the west coast, and a little bit more spill over there, and then some pretty severe convection going on through the central Mexico down there. I don't know if my radar goes that far. We'll see what we can do. Pull up some radar, but I do want to look at these cells in Nebraska, South Dakota, Minnesota. See what do maybe some cross sections. See how intense these systems are. My guess would be right now looks like nothing severe, and with the sun going down and diurnal cooling, it's probably not going to be a major threat for severe systems. But hey, we can still get some hail with a cell like that, so they can go severe just based on hail and wind. So definitely no tornadoes, but we don't want to rule that out. So we'll pull the radar and look at that. First, let's pull up the see if we can get a good surface chart and see what kind of systems we're working with here. So my data's still downloading, so as soon as this is done, we can pull a surface. Let's go ahead and look at the national radar real quick. Okay, so we do have rain and snow over the Rockies, over Iowa, and then looks like maybe a little bit of a low pressure system just north of Minnesota, and maybe a frontal boundary extending down into right along that where we've seen those isolated cells through Minnesota, South Dakota, and Nebraska there. And then you can see the rotation on the radar through that low pressure system that was to the northeast, and there is a little bit of snow over the Canada, and Maine is just getting mostly rain. Looks like some pretty steady rain showers. So alright, so I'll go back over to see if we got this surface chart now. Got the data downloaded. Pull up surface pressure. Okay, this looks a little cluttered. So we got a low pressure system over northern Colorado and extending all the way up into Nebraska, South Dakota, all the way up into Minnesota. So our frontal boundary kind of be maybe a stationary front pushing down, and then that may be a low. We'll have to look at some data. These high pressure systems aren't really there. That's just the computer overcompensating for some ridging going on. Let's look at some data real quick. We can pull up the station plots and see where our wind flow is around these highs. Like I said, it's probably just ridging, so separating them, low. So we got high pressure ridging down. Looks like a big area that dropped down and then separated from this high pressure system. So the low pressure system over off the east coast, it looks like maybe a frontal boundary coming in, maybe stationary, separating these two highs, and then maybe connecting to a warm front coming out of that low pressure system. And then let's go pull up the isotherms, and we can see what kind of advection we have. But we got southerly flow going into Texas, so it's pushing all that moisture up. It's not a real strong flow. I mean, we got 10 to 15 knots, and then we do have some broken to overcast skies, mostly scattered, partly cloudy over Texas, and then pushing a little bit of moisture further to the north. Will be coming overcast over Oklahoma, and then Kansas, some broken skies. But wrapping around that high pressure system, or the lift from this low pressure system running into this high, we have a few areas of cloudiness pushing through Illinois and Ohio. So now if we look at the isotherms, they are perpendicular to the isobars. So isobars are lines of equal pressure. Isotherms are lines of equal temperature. Low pressure systems, the winds flow counterclockwise around the low pressure system in the northern hemisphere, and clockwise around a high pressure system in the northern hemisphere. So Bayes' ballot law says with the wind to your back, low pressure is always to your left. So if you're standing right there in Missouri and the wind is to your back, your low pressure is to the left. So if you ever wanted to figure out where low pressure was and you're facing north, the wind's to your back, low pressure to your west, and the weather throughout the United States travels from west to east. So you pretty much can tell if low pressure is moving into your area. Now, it might be pretty far out there and may not be there for a couple of days. So, but if you look at the clouds, look at the cirrus spill off, like on that satellite picture we had. So you can see, let me get it up over here, some cirrus spilling off. Now you could say probably in a couple of days we're going to have frontal passage over the Ohio Valley region. So just looking at the clouds. Just a little bit of rule of thumb. Not always 100% accurate, but that is a rule of thumb. All right, getting back to our chart. So low pressure system, we have the winds out of the south, winds out of the northeast. So we do definitely have a rotation here, winds out of the west. So winds are going to flow counterclockwise and into a low. So you have that low level convergence, which means the winds are coming together. So they're going to go into the low. They can't go down, so the pressure is going to go up. So it's going to create a lower pressure and go up into the upper atmosphere. Now, how far that extends depends on all the atmospheric dynamics going on in the upper levels. Location of the jet stream. Is there a ridging, upper level ridging? Is it upper level troughing? Is it temperature increasing with height? Is it creating a cap? Is it capping all that to the bottom? If you have an inversion, then that low pressure is only going to be on the surface and only extend up to that inversion, and then it's going to hit that inversion. It's just going to be capped off and then flow horizontal. So what you look for, like in Texas, you get that dry line, you can get a temperature inversion, and then you get the southeasterly flow onshore, pushing moisture in under that inversion, and the moisture just keeps building up, and then finally, once that temperature it increases with height, so you have a cap. So typically in the atmosphere, you have, as you go up, it gets colder, so temperature decreases with height. Well, when temperature increases with height, that creates a cap and holds all that. It's a stable environment, so it holds that instability to the surface. So if you get moisture pumping in off the Gulf of Mexico into Texas, and then you have a approaching dry line, then you can actually get the temperature change that as that moisture goes up, evaporates, cools, and brings that temperature down in the upper levels and breaks that inversion, and then it's just an explosion, and you can get actually some pretty severe weather really quick. Tornadoes, your dry line is going to be your lift, and then with that capping, breaking, then all of a sudden you have just significant immediate upward vertical motion, and you can get a tornado out of that. So something to keep in mind is whether they look at the dry line all the time. The dry line's like your front, that's going to be the trigger, and then your capping, that's like, it's a loaded gun. The capping just caps everything down, builds up all that pressure, the moisture, and then once that inversion breaks, that cap breaks, and then it allows the level of free convection, all that moisture to hit that, and your convection is just gone, and you're shooting up to 40,000 feet real fast. So all right, we do have a baroclinic low. That means the isotherms are perpendicular to the isobars. So we do have temperature advection. This is a pretty elongated low pressure system. If you look at the wind patterns here, we can see a southwesterly flow, a southerly flow. We're almost going easterly, east to southeasterly, and then back over here we're going northwesterly. So we do have some rotation to the north there. So you can almost put a low pressure system right there, and then really not a lot of advection right there with the temperature. So almost be like kind of a stationary front through there. It's just going to sit there. It's not going to move a lot, depending on how fast this low pressure system is moving. I'd say it's just getting started, or just starting to develop. And it is a closed low. If you look at this rotation, we do have the northeasterly flow, the westerly flow, the southerly flow, so you have a little bit of rotation right there. But you can't have two low pressure systems right there grinded against each other. Counterclockwise flow, counterclockwise flow. You got to have something to separate in that. So there's gonna be like a little ridging or stationary front or something's got to separate that. So if you look at the low pressure system, you have convection or advection, temperature advection to the south of that. So you could always put a cold front right there because you have cold air advection in this area. You have warm air advection in this area. So you could drop that warm front down. Then look at your temperature 76, 73, 76, 79. I mean, we don't have a big, giant temperature difference. 62, 73, 82, right there's your big difference right there. So, and the winds are from the south, and then they switch southeasterly, so you can almost put that warm front right over Wisconsin. It's like I said, with that low pressure system to the north right there, that would be, the computer's not labeling it, but that would be a low pressure right there, warm advection, and then weak cold advection right in this area. But that's not even, with that flow, you're almost like a little bit of warm air advection over there, so you'd almost be just an occluded low that the warm air and the cold air caught up with each other. So either the warm air is overriding the cold air is undercutting the warm air. So you got an occlusion, and then you bring that down into a cold front, and then bring that cold front back out of the trough of that low pressure system. So, but I didn't want to get that deep in all this, but I like to have you guys learn something as we go. Instead of just looking at charts saying, hey, there's a low pressure system, there's a high pressure system, let's go to the models, and then let's, everybody wants to know if it's going to rain, but you can go to any channel across YouTube and learn if it's going to rain. You can, these guys are chasing models all day long. So, and we'll chase the models too. I mean, we'll look at them. Models are a good tool to use, but if you don't know exactly what's going on in the atmosphere and understand how it's working, you can't verify those models are correct or not. So, you always want to be learning constantly with the weather. So, and that will never stop. Now let's go to, we can pull up, actually, let me go, I can throw the fronts on here real quick. It's computer generated. I don't care for them too much. I don't really ever take the time to draw them. I just kind of explain them a little bit, but I never draw them too much. But we can throw the fronts on here, the computer generated fronts, and they can just be anywhere. See, like low pressure, cold air advection, going into another low, and that just generated its own low pressure systems, too. So now you got trough, low, cold air advection. Like we said, they're probably because of cold air advection back here, but I put that cold front back into that trough a little bit further, and then warm air advection, like I said, up further. We do have an occlusion further to the north. That is what this is showing. I'd bring that occlusion probably further down into that low, right into that rotation, and then break my cold front back, and then more of a stationary. I would call it stationary. I don't see it moving a whole lot, and then bring that warm front out. So let's go over to the satellite. Let's go back to that satellite real quick, and then we can just look at where that convection was, and you can watch the where that pops up. It just kind of pops right up along into Nebraska, up into Minnesota, just kind of riding right there. And look at this system. I mean, it's not moving very fast. It's pretty stationary. That's that low pressure system. So this stationary front, I would call it a stationary front, just bringing it right down into that. Because, like I said, there's really no major advection right there. So let's go. So I would just go stationary. I mean, that's basically what they're doing right there. They're throwing a little bit of warm, cold, occluded back into this. I would say stationary through that low. So there's through Nebraska and then into Colorado. So that's pretty accurate there, I would say. Let's go to the models. Just to see what they're going to show us, and then we could pull up some radar. Let's pull up those systems. I want to pull up those cells to the north over South Dakota, Nebraska, and break them down a little bit and see what we got going on there. So right now we are tropical tidbits. We are on the first model run. Okay, there's that low pressure system over Colorado, troughing lee side of the mountains. Now, getting a little bit more convection there. Rain. We did have the moisture. There was a little bit of broken clouds. Not a whole lot over that area over South Dakota. So, but this is a forecast 36 hour 06Z on Wednesday. It's like 2 in the morning Eastern time. So we go a little bit of convection in South Dakota, a little bit over Wisconsin, and then that low pressure system over Missouri. So we got the low pressure system. We still got some cold air advection, troughing, and so that's becoming a more well developed low, a little bit tighter, and bringing that cold front to the east. Now we're getting some wraparound moisture over Iowa, a little bit of convection to the north over Minnesota, and then we're getting into some pretty intense convection over Mississippi, stretching up into Tennessee. So now we get more of that dropping to the south, staying over Mississippi mostly, and then stretching into Alabama, and then most of it just fills and dissipates. So this is Thursday, 12Z. That's 8 Eastern, 7 Central. And that low pressure system, like I said, it's moving pretty slow, so it's just kind of wandering around right there in Iowa, circled around a little bit, and then it starts pushing off to the northeast, and then it looks like it's still there, but it's not being indicated as a low. You can still see the isobars are still closed, so that low is filling pretty quick. And then looks like another low pressure system just jumped in over Texas, and now that's pushing to the east over Louisiana, causes pretty severe convection, so possibly some severe storms down there. And this is April 10th, Saturday, 06. It'll be at 2 in the morning, maybe 01 a.m. on Saturday for Central Time. So that pushes east. Low pressure, now it's definitely a closed low over the panhandle of Florida, and that's becoming pretty severe, pretty intense storms right there over the panhandle. So we have to keep an eye on that. It looks like I would say most of your severe convective weather, I mean, it's all over right there, but if you get a hook echo or something, maybe a push be off the coast. I'd probably see a few water spouts down there. All right, low pressure still over the north, over Wisconsin. Then all of a sudden that just drops way down over West Virginia, Pennsylvania, Northern Virginia, 996 millibar low, and then convection over the mountain range and pushing off to the northeast. So convection off the east coast of Florida, that's Monday on the 12th, so we're starting to get pretty far out there. We can just run this through and just see what's going to happen. I mean, this all changes daily, so looks like some pretty significant snow over South Dakota, a little bit over North Dakota, and then some convection right along with that line. Another low pressure system pushing through into Iowa and Michigan. All right, so back in here now. The low pressure system developing off the east coast, that becomes pretty intense over there. So it looks like most of the rain staying over Pennsylvania, southern New York, Jersey, convection over Massachusetts. So another low pressure system, lee side low, looks like a low pressure system popping up over Colorado, and then some rain showers and then snow showers over Wyoming. And we'll get a little bit more convection come in. This is Friday, 0Z. So it'll be like 7 o'clock at night Central Time, Thursday evening on the 16th. And then that convection moving out of Arkansas, northern Louisiana, over to Mississippi, and a little bit crossing over to Alabama. Dropping south along the Gulf Coast, and then we got some convection that develops over Texas also. So it looks like maybe a minor shortwave moving through. What do you got there? Is that a low pressure system? I mean, there are some isobars that are closed there, and then that pushes off to the east and then hits Mississippi and Alabama also. So there's another low pressure system to the north that comes out of, let's see, Colorado. That dropped to the south. Looks like it breaks off up to the north, and then just some rain showers. This looks like a closed low to the north of North Dakota and Minnesota, and then Oklahoma getting a little bit of convection there. So as this develops, we just have to keep an eye on it. I mean, we got some pretty intense stuff right there. At this is on April 18th on a Sunday. It'll be Saturday evening, and on the 17th actually. So we'll have to keep an eye on that on Alabama, down on the Gulf Coast there. That could be something pretty severe too. So like I said, just run these through. We got another low pressure coming out of Colorado, pushing to the northeast, and then moving over the Great Lakes region. It just looks like rain showers over the East Coast. But all of our convection staying south, a little bit to over the Dakotas, Minnesota, and then right there in Nebraska. That's a pretty good one, pushing into that low pressure pushing through Iowa too. So that could change too. We'll see how that goes, because Iowa, being out there in the plains like that, they get some pretty strong winds and get some wind damage. So there it is for the models. Like I said, we could chase the models. I like to see the stuff as it's really happening, and then look at these low pressure systems as they develop and pull up the charts, and that gives us the real story. I mean, let's just go pull another chart real quick. I mean, jump up to the 850. Let's go up all the way to the 500. Pull that chart real quick. Let's see. We could pull up the contours. That's lines of equal height, moisture, and then our station plots for the stations that let go of weather balloons every 12 hours. So this data, the station data, is going to be 0Z. It should be 12 or 0Z. So about 8 o'clock in the evening. So about an hour old. So over the Ohio Valley, Wilmington let go of a balloon. We got 30 knots at 500 millibars. That's about 18,000 feet. Then we have a temperature depression. A dew point depression of 5 or less, that's where we get the moisture. Start getting this moisture when you get that dew point depression. The dew point depression is a difference between the temperature and the dew point. Once you get down within 5 degrees of each other, then that's when you are pretty much saturated. So you have significant moisture. So we got a contours and the isotherms are pretty much parallel to each other. So that's not a real significant any advection going on. So we do have ridging in the upper levels, troughing to the west. So with that low pressure system over Nebraska, and then stacking back up to the 500 with the upper level trough, then we do have upper level support for that system. That's why that system will continue to develop. So if we go back one more and go up to 300 millibar or 250 millibar, let's go and pull up the jet stream real quick, just to see what kind of jet support we have for that system. And there's our jet. So low pressure over Nebraska, jet stream pushing up over the ridge. So we do have that low pressure system does have jet support. When you have upper level winds over a low pressure system, then you do have the winds can suck the mass out of that low pressure system and cause it to deepen and become more intense. So when you have jet support, that is a big indicator of that system is developing stronger. So the contours on there. There's the trough and the long wave trough. There's a cold, I guess that would be more of a warm core in the upper levels. Minus 50, and then going out to minus 52, 54. So we're warmer over the mountains. And then, so with that stacking back to warmer air, with that troughing, then we do have a little bit of advection right here too. So that brings out as a pretty intense at and ahead of that trough with the advection, we got the lift and the instability that we need to support that low pressure system on the surface to cause storms or any kind of weather down at that surface. Go pump up some volume on this these station plots, get us a little bit more, a few more station plots on here. So we're looking at our jet max about 90 knots. Actually, we were at 100 here, 110 for the jet max, then shooting up to 90, and then out to 70, and then pushing up over the ridge, and then coming back to the south, from the northwest back into the southern finger of the jet. So, like I said, we do have jet support. That's a big deal. All right, let's get to the radars where everyone wants to see. Let's go look at these cells. All right, let's pull up the window, the warnings window. Let's see what we got. We have 2 warnings in Minnesota, 1 in South Dakota. So we look at South Dakota. For severe thunderstorms. Here's Minnesota, South Dakota. So let's just go look at this real quick. We got some pretty intense reflectivities there. It's about 65 dBz. We go download the loop. All right, we are reporting some hail there. Let me go pause this for a minute. So it's like 1 inch, 1.46, almost an inch and a half. So that is definitely severe weather. So let's do a cross section on that. There's our updraft. That's pretty intense updraft. That's up to 65 dBz, almost up to 30,000 feet. So that is a real intense updraft. Not a lot of tilt to that storm, just pretty straight up. But that thing is definitely cranking the precipitation in the upper levels all the way up over 40,000 feet. So the base velocity looked like some rotation up in that upper levels. Let's go do a 3D shot on this. Alright, so drop this drop these reflectivities so we can drop this down to our more intense reflectivities, the red, oranges, and then the higher reflectivities. Now we can see our updraft. Like I said, we're cranking all the way up to 40,000 feet, over 40,000 feet. And so you can see from the southwest, you can see that updraft. And then let's get this. That's the whole system there. So overshooting tops, anvil. I'm actually pushing over here. The anvil's going to be from the west to the east, so it's pushing off, and then overshooting tops. Right there's our updraft. So that's where the most intense updraft is going to be, right there in that area. So we can actually pull rotation on this thing. We do got a little bit of rotation. Let's go pull up another. Let's look at the winds for the rotation. See what we got here. So our let me get out of that. I'm gonna change my pointer. Okay, so our radar's to the northeast. So the hot colors, the red is going out from the radar, the green is going in toward the radar. So most of it's going in. We're on the outer edge right here, but right there where that hail is. I mean, if that's is accurate, then let me go to storm relative velocity. So that gets rid of any storm motion, and tells us what the velocity is. So we're at 49 knots right there. We go back to the base velocity. So it looks like 49 knots on both sides of that thing, so almost 100 knot of wind shear. So, but that's if that one's accurate. So, it's, like I said, it's on the outer edge of that radar scope. No, it's not, because our radar's shooting all the way out here. So, you know, we're cranking pretty good right there. There's the hail. See if we got any other warnings pop up here. Let's go to the upper levels. See, we're still cranking up to, it's mostly on the surface. So let's see, we're 1.4 degrees, 4,900 feet. We're about 5,000 feet. We do have rotation. So we're not rotating about 10,000 feet yet. So you get up into them upper levels, then if we see a rotation up in here, you definitely see a warning. So that most of that rotation's in the lower levels. So that's what we gotta look. We gotta make sure I'm, you know, once I pull up that surface, see, we can pull up the surface here for the base reflectivity, go up into the upper levels. Now it just disappears. See, there's nothing all the way up in the top of part of that radar. Now we do go pretty intense, don't get me wrong. We're going up 40,000 feet, so over 40,000 feet, and you got 50 dBz's. All you need is 50 dBz's at 10,000 feet, and you'd be, you know, you could produce severe weather. And this thing already is with the hail, you know, 0.97 inches right now, so it's just less than an inch. So we go up into the upper levels. If you watch this, go down to the surface. Here's our main cell. That's the updraft. We're going to push that up. Now we start to dissipate, and then we start to push over a little bit further to the east. That's our anvil right there. That's what we're seeing right there. The anvil being blown off right there. So here, let's do a cross section real quick. So pretty much like that thing straight up, and we don't really have. We do got some of an anvil, but we're that's a pretty much straight up cell. That's why we're not seeing rotation further in the upper levels. The updraft is just going straight up. It's not going at an angle. Once an updraft goes on an angle and you start dumping precipitation real heavy, then you'll start creating that downdraft, and then you got an updraft and a downdraft, and then you can get them two wrapping around, becoming that tornado. So we're not quite there yet. That's a pretty small cell too. So let me go to let's go up to these warnings up here. Now we're starting to get a little hook right here, and they're not calling. That is definitely severe, but they're not. There's no tornado warnings or anything yet. That's a 1.25 inch hail being produced on the outer edge of that thing, so definitely got an overhang there. Let's go look at updraft. Let's see what we got here. All right, so now we see our overshooting tops to over 40,000 feet. Look at rotation. Definitely got some pretty strong rotation from the surface. Really just about 5,000 feet, right about where the other one was. Pushing up into the upper levels. Let's go see our base velocity on that. Let me get rid of this. Still not showing any kind of rotation there. So let's see what we got for a let's go pull up another local radar and see if there's anything showing up on that one. Sometimes you'll get a radar with a different angle, and then it'll show you a little bit different rotation. So we got a little couple green pixels in there. So all right, so that is 51 knots. 51 knots. Showing 17.5 knots to 8 knots. Looking right down at the bottom. I don't know if you can see that. No. So, trying to look for some rotation right there. I'm just thinking that we're not really seeing much at that point either. So that light green would be going into the radar, the red out. So we're just not seeing it. Let me get back to this radar. Okay. See, we're not there. Now let's go to the upper levels. Pull that radar up. Now we're getting something here. Now our radar is to the southwest. And that would be more of a clockwise rotation. So that's probably just an anomaly. That's nothing there. I want to see counterclockwise. See, like the way this radar is showing right here. You got winds going into the radar, out of the radar. So now you're getting in, out. So now you got some divergence right there. Convergence right here. But we're still out of the morning area, so 3/4 inch hail, 1/2 inch hail. I mean, we definitely got a hail producer. Let's go back to the lower levels. Base reflectivity. Let's go for our vertical integrated liquid. Now we're getting up, to the higher levels where our precip's being pushed up. And let's do a cross section on that. Let's see. Let's get over here. See, we're still pretty much, well, we got a little angle right there for the updraft. Now we got overshooting tops here. Push into the east, from west to east. So we got, looks like an anvil here over 30,000 feet. And then we do have an angle for that updraft. So this thing definitely is severe, but we could go a little bit worse on that if it develops a little bit better. We're seeing that little bit of a hook there too, so I don't want to do a cross section. Let me get my pointer back. So we have to keep an eye on that one. Let me go to pixelize this a little bit more. That gives us a little bit more data on each one of these pixels. That kind of helps out for picking it out, making it smooth, makes it look pretty, but sometimes you lose some data. So anyway, that warning, nothing there. Here's one to the northeast. Do a cross section there. All right, we're gonna really see, almost coming up on 40 minutes for this video, so starting to get an itchy throat. Just got over a strep throat, so I don't want to make this any worse. There's that one. That is not in a warning area. Right there is pretty intense. And that's pushing 50 dBz's up to about 25,000 feet. So that's pretty vertical too. So, and I keep forgetting to change my pointer, so to move this around. All right. Okay, so pretty intense cells, pretty small. As these storms start pushing through, we've seen quite a few storms pushing through Louisiana, Arkansas, mostly Arkansas, Mississippi. Mississippi was getting hit pretty hard. Mississippi, Alabama, and then some other isolated stuff up here to the north, and then a little bit over Texas. So as the week or two goes by, we'll do another video. We'll start working with this radar a little bit better, and try to get used to this thing. Let's go. Just practice for a minute here. Let's see. Get rid of. And we get that. We're zoomed out pretty far. So now we get down to the red. That's where we get to the 50 dBz area. We definitely got some purple in there too. It's about 65 dBz's. So there's definitely purple right there. So keep missing it. Okay, so that is almost 30,000 feet. So that's a pretty intense storm. Not a lot of volume there for that reflectivity, but 50 dBZs and higher, 30, 40,000 feet, that's pretty intense. So then we bring our precipitation, the green, all the way up. And that's pushing, 50. Got this thing, I got too big of an area, so I can't really read my heights. 50,000 feet. And then you get into the lower reflectivities. This is definitely rain and cloud cover, so you get into this really larger area of cloud cover. So, but if you look at this, you can see the overshooting tops. Now a lot of this is just radar, clutter, because the radar shoots out beams and it gets readings back, and it has to happen really fast. And the faster that happens, the shorter the wavelength, the slower it happens, the longer the wavelength. So that kind of throws off a little bit. That's why you get that chopping. So, all right, but pretty cool. Let's get a little more practice with this thing. We'll go up into these upper levels. Possibility of severe hail. There's a hail size of over 3/4 of an inch. Just pulling up different spectrum width, echo tops. Here's our echo tops. What we got there? 40,000, almost 41,000 feet. So, and I'm still stuck on my, gotta remember to get that pointer changed over. Right, so that's right around the radar. The echo tops, you'll get some weird stuff like that. Alright, so let's do one more model real quick and just run through this. This is another GFS. I mean, same thing as we were looked at before, but this is a Navy runs this model. So got that low pressure system off the lee side of the mountains. Now here's our convection. We're showing pretty good through South Dakota, Nebraska, up into Minnesota. So with our radar, actually let me go back to that radar. So that's pretty accurate right there. Okay. Isolated cells. See, this is April 8th, 0Z, Thursday, and that's got that pretty intense band moving through from Arkansas into Mississippi, and then even further south, Louisiana into Mississippi, and then as it pushes into Alabama, it starts to weaken. I think the other model was showing a pretty intense cell shooting over the panhandle of Florida, but that might be later. Maybe right here. Here's one that's actually keeping up in Georgia, Alabama, then mostly in Georgia. Then we have another system. This is Saturday, the 21st, Louisiana into Mississippi, and then Mississippi and Alabama. Pretty intense there. And then looks like some isolated cells over Alabama into Georgia. So this model's running a little bit different. And then most of the intensity stand to the south off the panhandle. So there's that one. And then the low pressure system moves off to up the east coast. Alright, and then another low pressure system over the Gulf. And this is pretty far out. April 13th, 0Z. So I think the other model went further out. We went out to the 17th. So that was the other system that we were showing in Alabama, Mississippi. But like I said, you get that far out, it's take it with a grain of salt. So anyway, I want to end this video here, and I want to thanks for watching. And do me a favor, hit the thumbs up, like my channel, make a comment, help me out with YouTube, and stay tuned. And we'll get deeper into that radar as we get some severe systems. We start getting some tornado warnings. We'll start pulling up some of that 3D radar and see how intense this thing is and what we can do with it. So once again, thanks for watching, and visit my website, meteorology101.com, if you want to learn some pretty intense, deep details about weather. And as I do these videos, I'll keep doing a little bit of teaching as we go through the models and the charts and maybe learn a little bit. All right, thanks again.